Welcome back, differential equations students. 4.9, video 2 here. Okay, we'll see if I can't pick up my pace a little bit. I know I kind of take my time here and there, so we'll see if I can't, speed it up a little bit, because I know you guys can slow it down if you have to. Here I'm going to write my first thing in operator form, so I have a dx, right, plus a d squared now of y, that's this term here, equals t squared plus a 4x. Then I would have a dx plus d squared y equals 2t squared minus x, right? Okay. Already here you can see that we have some issues arising, mainly because of these t's, okay? But we'll continue. There's no need to freak out super early, okay? No need to. What I've done in the past is I said that I'd like a, standard form. Well, the standard form in this case would be all of the x's and the y's together. So this is dx minus 4x plus d squared y equals t squared. Then I'd have a dx plus x plus d squared y equals 2t squared. I'll open up. I've done it again. I made this problem way too easy if I have these squareds in here. And I do apologize here, but I did not want this squared here. I just wanted it to just be a d. Okay, just a d. So of course that changes things over here, because now they don't just cancel out. Nice and easy, which is good. This will be good for our practice, right? So I've gotten this in standard form with my operators. Now I need to make the match. Okay, I need to make the match. This one here can be a little tricky sometimes, right? How do you make the match? I got so much stuff going on. Well, again, it's very helpful normally to write them with things factored out. So like I see that these share an x, so that's minus 4x plus d squared y equals t squared. Then I have a d plus 1x plus a dy equals 2t squared. Okay, and at this point you can kind of choose, right? We need to eliminate something. You could choose to eliminate the x's by making this d plus 1 go up here to the top one and d minus 4 come down here. That one looks a little harder, honestly, because I see that these terms are really close. All that I'd have to do is multiply this down here by a d, and I'd have d squared, right? Don't forget, though, I want it to be opposite, so a negative d would be most optimal. So what would that do to my equation here? Well, let's just write it like this, right? I'm multiplying this out on the bottom. Right? And that's what I would have, okay? Shouldn't be too bad. Essentially this top one went away, right? This is gone now. And if I look at it, I think I'm ready to combine these two equations. These cancel out nicely for me. This operator d, okay, right here, we can either choose to leave it for now, well, or we can think about what does d here represent, or what should I be. And I think it's super smart here that we realize that this is d dt, which means this is the negative derivative of t. Oh, that means this whole thing right here is actually just, well, 2 times 2, that'd be a 4t, and it's negative. I'm adding, though, so when I take this and this, I'd have t squared minus 4t. That's on the right side. On the left side, then, what do I got left? Well, I'd have a negative d times d minus 4 times a d plus 1, and all of those had an x. Well, let's see if we can't do a little bit of simplifying now. And I've almost made a crucial mistake. I'm sure you guys caught it. Let's go right back to here, okay? I almost made a very crucial mistake. It is this thing here, which is d minus 4, plus, which with this negative, it really becomes negative d times d plus 1. Okay, I'm sure you guys caught that already, but I just want to make sure. So that's a d minus 4 minus d squared minus d all times x. And what I want to do here, right, is I see that these well, give me a different color. These cancel. So I have a negative 4 and a negative d. I think it would be worth it maybe to pull that negative out, which would then make this d squared plus 4. X still here equals t squared minus 4t equals t squared minus 4t. Okay, well, what now? Well, I see this as a negative here, so maybe it'll make sense for me to put that negative on the other side. And we're back to our auxiliary equations, okay? This would have been back in Unit 2. I should have shown this in Unit 2. I think that's where it's from. So feel free to go back and check out your Unit 2 notes. And what we did in Unit 2 is we made this homogeneous. So we acted, right? Like there's a 0 here, which means the x homogeneous solutions are this d squared plus 4 equals 0. That would give me the answers to d squared plus 4 equals 0. Well, of course, we know that d would equal plus or minus 2i. Again, we've seen this stuff many times. This would be alpha equals 0, beta equals 2. So we know that the homogeneous solutions are equal to c sub 1 cosine of the 2 with the t, and then plus c sub 2 sine of 2t. Okay, that's great. Of course, we pretended like there was a 0 here, right? But there actually isn't, which means I have to go after the particular solution. Okay, the particular solution. And what we did back in that section, or back in, I believe it was Unit 2, check my notes there, okay, is we used annihilators. And I want to know what annihilates this thing up here. Well, it's real simple because they're just this squared and this t. Real easy. I just need d cubed, right? Okay, if it's d cubed, then that essentially creates, right, 0 with a multiplicity of 3. Have we used any zeros over here? No. Well, then that means y sub p, the particular, or I shouldn't say y. Sorry. It's not y. And it does matter, so x sub p here would be c sub 3, because I've already used the 2, plus c sub 4t plus c sub 5t squared. Again, each one of these terms technically has e to the 0t, right? But that's 1, so I can just have those drop out. All right. And I'm sure some of you are thinking, well, just take this homogeneous and the particular and add them together. That's what we did before. But you got to remember, we are not allowed more than 2 arbitrary constants. So I actually have to get rid of all of these constants. Well, how did we do that before? Well, before, what we did is we found the derivatives, right? Which would be c sub 4 plus 2c sub 5t. And then we need x double prime, which would just be 2c sub 5. These should, right? These should be solutions to, and this is where you have to be so careful. You have to be so careful. This is what makes this section a little bit difficult. This should be a solution, right? This x sub p, the particular, should be a solution. So maybe I'll even write this out. X of p should be a solution to, where was my auxiliary equation? This one, of course it jumps, right here. Okay, it should be a solution to that. So it should be a solution to d squared plus 4 times x equals negative t squared plus 4t. Okay, then let's plug it in, right? Let's plug this thing in. Of course, we could do a little bit of math here. This is d squared x plus 4x equals negative t squared plus 4t. I do need this d squared here, x, well, that's actually just x double prime, right? That's just x double prime, and then this is plus 4x equals negative t squared plus 4t. I know x double prime is 2c sub 5. I know 4 times, okay, well, my particular one was c sub 3 plus c sub 4t plus c sub 5t squared. And that should equal negative t squared plus 4t. Okay. Which shouldn't be too bad, right? We should be able to work this out. This would be a 4c sub 3 plus 4c sub 4t plus 4c sub 5t squared. And then this 2c5, I do think I'll just drop it straight down here in front because these here are constants. This is for t, and this is for t squared. Well, over here, I'm just playing matchup, right? I'm just matching these things up. Oh, t squared, right? This t squared, this 4x or 4c sub 5 should be equaling what's here with the t squared. So I know 4c sub 5 equals negative 1. Which gives me c sub 5 is equal to negative 1/4. I know that this 4t, right? This 4 with the t is supposed to be this over here. Well, that gives me 4c sub 4 equals to 4. Well, that means c4 is 1. Finally, I have a plus 0 over here, which means this whole thing for my constants, 2c sub 5, that was very messy, c sub 5 plus 4c sub 3 should equal 0. I already know what c sub 5 is, so that's 2 times negative 1/4 plus 4c sub 3 equals 0. That's a negative 1/2 plus 4c sub 3 equals 0. 4c sub 3 equals 1/2 then. C sub 3 equals 1/8. Okay. And even though it doesn't like really feel like it, we actually have the solution. We do. The solution is always the homogeneous plus the particular, which in our case, the homogeneous was c sub 1 cosine of 2t plus c sub 2 sine of 2t. And then our particular solution with the variables filled in would be plus 1/8 plus t minus 1/4 t squared. And then I have x of t. Now I have 1/2 of the answers, right? Okay. Of course, we're not quite done, right? We need to now get y, which means that we actually need an equation. I need an equation. Now, you can choose whichever equation you want. You really, really can. And I want to really push that. But this one here just looks easier because I don't have to deal with squareds, right? I don't have to deal with double primes. So if I can remember what I just looked at, right? That was x prime plus y prime equals 2t squared minus x. Okay, so I need a few different things here. Looking at it, I have x, right? I would need to solve for y at the end, so maybe I'll just solve for it now. Right? I can solve for it there. There's nothing wrong with that. And from here now I need to plug in stuff, right? So y prime is still here, so it's y prime equals, well, 2t squared is not going anywhere, minus, okay, then it's this entire equation. So what, instead of writing this all out, right, I think you guys can do this here. This is minus c sub 1 cosine of 2t minus c sub 2 sine of 2t minus 1/8 minus t plus 1/4 t squared. Okay, and then it's minus the derivative of x. Okay, well, this can take us maybe a little bit of time, right? Here I would have to make sure that I'm taking the derivative correctly, right? So as I go down through, I'm not touching this. I am touching this here, though. It'd become a negative 2 c sub 1, and that would be a sine of 2t, right? But the derivative of cosine is negative sine, so this would have to become a positive. Then I would have, okay, this would be derivative of sine. Well, it's going to be a negative 2c sub 2 cosine of 2t. Would I need to change that negative? No, because the derivative of sine is cosine. Then I'd have negative 1/8. That actually goes away. This would be a negative 1. And then this one would be a positive 1/2 t squared. And I was kind of clever. Remember, this is all in one giant line technically, which means I can actually just combine some stuff as I go through, right? I should be able to combine some things. So here I have a 2, maybe I'll highlight it, 2 c sub 1 sine 2t. And over here I have a negative 1. So that should make, but this one has c sub 2, this one has c sub 1, which means I can't actually combine those. Okay, that's a little bit frustrating, right? A little bit. I can't combine those. Okay, so that would be a 2 c sub 1 minus c sub 2, and they both have sine of 2t. Next, I see the cosines, and they're both negative, right? So I could write a minus sign here, but for completeness, maybe I'll just keep it kind of the same. I have a negative 1/8 and a negative 1, which would make a negative 9/8, right? I have a negative t, nothing else with it, right? And I can't forget actually that this 2 here doesn't exist because I took the derivative. So those two would combine, which would actually make a negative 1/2 t. And then finally, I get my 1/4 t squared and a 2t, which would make 9/4 t squared. Okay, and don't forget this is y prime equals this whole thing, right? Well, the goal is to just get y. How do you undo the prime? Well, you take the derivative. Assuming that it's all against just t's. Well, it is over here on the right side. So I take the derivative against that, and I'd have y of t equals what, this one here would be c sub 2 minus 2 c sub 1 all over 2 times cosine, because I would have to take the negative version of that, right? So that's why I had to turn that around. It would get another 2, so I have to multiply that in. I don't think that's terrible. Of course, you're welcome to pause the video and make sure you understand that. Then I have plus a negative 2 c sub 2 minus c sub 1 divided by 2, and that would be the sine of 2t. Okay. And finally, I do these other little tiny ones. This is negative 9/8 t. That would be plus, let's see here, that'd have to be, well, it wouldn't be plus, it would be minus 1/4 t squared. And I would have plus 3/4 t cubed. And then technically here I'd have to put a plus c sub 3 in here, right? Because I would have to go through and add in that constant, okay? Add in that constant because I did just take a derivative, okay? Now the problem is that's not supposed to happen. I'm not supposed to have that, okay? How could I get rid of this c sub 3? Well, a couple different options. One, this is supposed to be an answer, right? So you can plug it in, okay, and check and work it through very similar to how we did, where was it? Yeah, right here. Very similar to how we did the particular, okay? In this case, I'm not going to go through and I'm not going to find it, okay? I'll leave that up to you, but you definitely could do it. You could plug it into here too and double check it and see what the c sub 3 comes out to be. If I ask on a test to find or only allow or follow constant rules, then you'll have to get rid of that one there. Okay, but I think I'll leave that as kind of a challenge piece for you. And that completes the video number 2 over our second example. Okay, over our second example. I am going to do one more video, okay, over our final example in 4.9, unless I choose to do a fourth one with word problems.